today we have reasons and solutions. This is what I already showed you. If you are pressurizing the house, it's not very stable. But the first question is, why are buildings not airtight? Well, they are not airtight because there is an imperfection in the building envelope during construction. So the construction phase is very important. Building structures during its lifetime are not rigid and not unchangeable. So that means that the components are moving and are not always on the same place due to building settings, temperature variation over time, and moisture variation over time. And it's difficult to make buildings airtight because of these three things. Well, where are the leakages? In the roof, in the walls, in the floor, but there are also what we call the miscellaneous leakages, internal leakages between internal components, but also connections to other or adjacent buildings. If you look to the imperfections in the building structure, if you look to the construction, there's material leakage, although the material itself doesn't leak too much. There are the connections between the building elements. We have cracks or seams of movable windows and doors, and we have penetrations. And we will also focus on penetrations later on, because one of the manufacturers will show solutions for penetrations. Penetrations can be outlets for ventilation or an outlet for combustion of the heating, combustion products of the heating plant. The ducting of the sewage or soil pipe in the floor, in most cases, can be a leakage, and electrical connections or electrical wiring. This is one I already showed you yesterday, but just to remind you, if you have an N50 of 1, 40% of the leakage in the Netherlands in 2010 was about in the roof construction, 30% was in the wall construction, and about 30% was in the floor. Where are these leakages situated? This is one of the roof penetrations, so we always, or almost always, have penetrations through the roof. And this is sometimes an important leakage, so we need solutions for this part of the, let's say, the roof and the penetration through it. Another important one is the connection between the facade and the roof construction. This detail is very sensitive because it has also to do with quite high pressures and distortion due to temperatures and so on. Floor penetrations are also important. They are sometimes, you don't see them sometimes, but there can be important leakages, especially in kitchens and in kitchen cupboards. The connection between the building elements, the floor and the facade is an important one. So we hope to have some solutions later on from industry of all these examples. And finally, you have the cracks of the movable parts in the windows and doors, which are, let's say, you cannot get rid of them because these parts have to move because we have to go in and out. Okay. So, what are the principles of airtightness? The principles are that we have a flexible sheet or a flexible connection between construction parts. And this flexibility is very important, and it's not always that if you have something which is flexible, it is okay, because the flexibility must be enough to fill the gap also during the settings. Then we have the flexible closed cell foam between parts, mostly under pressure, to close or to tighten the connections between building parts. You can have flexible kit or putty or whatever, flexible things between penetrations and the construction, and there are special seals sometimes developed. I hope we will see something also in the next presentations by industry between the penetrations and the constructions. The material itself is in most cases negligible. If you take plaster or concrete, the leakage through the plaster or concrete is negligible if you look to the airtightness of buildings. Well, we developed a kind of matrix structure where on the horizontal axis we have the construction type, for instance, blocks where the air tightness is made with plaster, or poured concrete where the concrete itself and the plaster is airtight. We have wood structure, but the air tightness is made with an additional membrane, flexible in most cases, and we have metal framework, and I know that we have some information about that also in this session. And then we have the vertical, the junctions and the penetrations, the junctions between the different building elements, between the wall and the cross, the exterior wall and the cross wall, between exterior wall and floor, roof and gable, window frame and wall frame, and the junctions between the base and the wall. And we have penetrations through the wall, but through the floor and through the roof. And above that there are internal leakages. And if you put that together, we have a matrix here with, here you see the, let's say, the leakage points in the building, and here you see the construction type. And what we hope now is that industry will show us where these gaps, how these gaps can be filled, and what kind of solutions they have for these, let's say, imperfections in the building structure to overcome the problem of air tightness or air leakage, I have to say, air leakage in buildings. So with that, I finalize my presentation, and we go over to the first industrial presentation.